Just a quick note, we may have investments in some projects discussed on this podcast. However, nothing we say should be taken as financial advice or a recommendation to buy or sell any asset. Please always remember to do your own research and never take our discussions as a recommendation to buy or sell any asset. Thanks for tuning in and on to the show. Welcome to the Friend Zone presented by TokenSoft. Today, I'm here with Bram Cohen from Chia Network. Chia Network is a blockchain where you can tokenize any asset and transact anytime, anywhere. Bram, I'm really excited to have you here today and to learn more about your background in Chia Network.
Good to be here.
All right, so you have probably one of the coolest backgrounds of all the founders in the crypto space. And, I guess where to begin, really?
Yeah, it can be summarized pretty quickly. I created BitTorrent. That's my backstory.
Okay, amazing. How'd you get started in that? What inspired starting BitTorrent?
Oh man, that was a really, really long time ago. I worked on a project called Mojo Nation in 1999, which was a cryptocurrency. It's kind of hard to have a cryptocurrency when mining hasn't been invented yet, but if Ripple's a cryptocurrency, then Mojo Nation was a cryptocurrency. And that project was really a glorious failure. It was way too ahead of its time. It was trying to do too many things, but it was a direct inspiration for BitTorrent and Bitcoin. So yeah, there aren't very many failures that are that successful as failures. But while working on it, I didn't think I'd gotten very many things to actually work because it was trying to do too much stuff. But the one piece of it where I thought I'd made some progress was in doing swarming distribution, because it was actually supposed to be like you were paying for storage on this thing using the token and blah, 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 blah. Stop me if you've heard that before. And I keep telling people Mojo Nation is not going to happen. Stop trying to make Mojo Nation happen. But I decided to do a project that was just swarming distribution and nothing else. And so that was BitTorrent.
For the folks listening, tell us a little bit about what swarming distribution actually is.
Oh, swarming distribution is that you have some data that's getting out, some file that a lot of people want. And the idea is that instead of everybody all downloading it from one place, people kind of send pieces of it to each other.
Amazing. And, when you guys launched Chia Network, the one thing that sort of stuck out to me was it had a very novel consensus mechanism. And I'd love to learn more about the inception of Chia, what inspired it, and then how did you come up with the proof of space and time?
Well, the story is I was avoiding touching Bitcoin because it sounded super sketchy. And, I was around during the dot-com boom. I absolutely hate just these investment crazes based on nothing. So I was like, I don't want anything to do with this. But some friends of mine were like, Bram, there actually is an interesting thing in there. You should go look into it. So I was looking into it and spent some time poking into it. And then I kind of happened across the Bitcoin Wizards IRC channel. And I got on that. And all of a sudden, everyone joined because it's like, oh, shit, Bram's here. Because they'd been expecting me. They knew I was going to show up sooner or later. And so I was talking to people on there. And Andrew Polstra sent me a link to the Bitcoin Wizards ASIC mining FAQ, where it makes the case that you can't do better than commodity mining. Trying to make things ASIC resistant is a pipe dream and a bad idea, and it all just boils down to burning electricity anyway, and the best you can do is make your mining rigs super cheap and commodity. And we got into an argument about this. And at the time, I was arguing, hey, memory hard proof of work will do better than this. You could, get rid of all this electricity usage, right?
Interesting.
You don't want to be burning all this electricity, not really doing anything, right? But it turns out that's wrong. Trying to make things memory hard doesn't fix the problem. And so I thought about it and eventually came up with the idea of proof of space, which other people had come up with as well. Now, proof of space seems to fit the bill. Because storage is just storage, like bits are bits, there's no super optimized version of it that you could have as a specialized piece of hardware for doing it. Any such thing that does that is just a hard drive, right? But there are problems with getting this to work, and they kind of fall into two broad categories. One of them is there are what's called Hellman attacks on it, that the obvious ways of doing proof of space algorithms just get busted. There are ways of using extra computational resources to get credit for more space than you actually have. And the other set of issues has to do with when you've made it be very cheap to run the blockchain forward, someone can just run forward like a million different versions of it, find out which one works best for them, and go with that. So that first one is extremely insidious. You really have this problem that your attacker is on their own machine. Like literally they are attacking their own plot format on their own machine with a very large attack surface here.
Which path was that one?
That's your fundamental proof of space primitive can be attacked by grinding.
Yes.
And there's just a lot of ways of being clever. You want proofs of space to make it so that not only don't you need computational resources on it, but you can't use computational resources on it. And people are, clever. So I managed to come up with a construction that fits the bill for that. Although actually we're working on a second iteration of it because people figured out how to do some attacks where they do some kind of hinting. They use a different format of plot file that hints at some information, gets better stuff. That's a whole other category of attack, and we are in the process of iterating on our proof of space algorithm to stop those kinds of attacks.
Interesting. People are already gaming it.
Well, it took a while for people to figure out how to do that.
Yeah.
It held up for a while, and it didn't completely fall apart, but it has more trade-offs than we like. And the new one looks really, really good. I've been spending a lot of time working on that, and we're getting close on being able to roll that out. And that'll really fix those problems for a good long time. The other set of problems that I said is that you can rerun history many, many times. There's a few techniques for improving that. One of them is you make everything completely canonical. So there's all these computations, and the output of it is very strictly defined by the inputs, and you can't just change things around and get it to give a different output. So that way you can't just monkey with your challenges that are going to come up. The other component of that is you need to mix in proofs of time to go with your proofs of space.
How does that work, and what are you solving by incorporating that?
Well, it makes it so someone can't just like rerun history. Like the easiest attack to explain is say that we have a situation where today the net space is much, much larger than it was in the past. So you have some cabal of people who decide they just want to make a blockchain that has greater weight by rerunning the last several years of whatever, and they have not greater weight than exists today, but much greater than there was in the past. So you take their weight times the time this blockchain has been around is greater than the actual weight of the actual blockchain. So what you do is you mix in proofs of time, that the weight of everything you create is, the time, the number of iterations of your verifiable delay function times the amount of space that you put in. And because that's in there, someone can do this rerunning of blockchain history on top of whatever else they're doing, right? And it's not really costing them that much to do that. However, they are continually falling behind as they do it, that they are entirely capable of making a greater weight history of like the last 10 years, but it's going to take them 10 years of real wall clock time to do it. And so they never catch up. That's the idea behind that. So in Chia, you have farming instead of mining, which is very close to mining. But people who are doing a proof of space, they take their proofs of space and they publish them to the network. And these aren't finished yet until they get incorporated by a Time Lord. There are servers called Time Lords that are running these very fast hardware versions of these verifiable delay functions on them. And they are incorporating these into the chain. And then only after the verifiable delay function has run a certain amount of time do you find out what the later challenges are for the upcoming blocks. And this is fairly secure in that the Time Lords don't have very much optionality in what they're doing. They are performing a canonical calculation that has a fixed exact output. You don't know what it is a priori, but any two people who do it will get the exact same output value for it unless one of them like skips a block. That's the only real optionality you have in it.
So talk me through who's accepting transactions, doing block proposal, and then who's doing the mining. How does that architecture all come together?
Well, there's a mempool, and there are full nodes that are in the mempool. You get this kind of intermediary thing where, in Bitcoin, you have transactions that are in the mempool, and then eventually the transactions get put into a block, right? And in Chia, you have transactions in the mempool, but then you have completed blocks in the mempool. And then on top of that, you have the actual chain that's getting distributed. That these blocks that are in the mempool get incorporated into the actual chain that's held together with proofs of time, attaching things to each other. So everyone who's farming, when they get a block, they make their block and they push it out, they publish it, and then it goes around the network, and then some Time Lord out there somewhere goes and completes it. And it doesn't really matter which Time Lord it is. An important part of this architecture is because what the Time Lords do is well defined. If like one Time Lord goes out, another one just takes over and is doing the exact same thing, maybe marginally slower than the first one.
Can you spell out that word? Is it Time Ward or Time Lord?
Time Lord.
Time Lord.
Yes.
I love it. So can anyone be a Time Lord, or only certain people can do that?
Anyone can be a Time Lord, but you're running these proofs of time continually. That machine is running the whole time it's doing it. And how fast it is matters a bit. Like what the network really needs is a few very, very fast Time Lords so that nobody can get an unfair advantage where they have access to a faster Time Lord than anybody else.
Interesting.
And the Time Lords that are actually running are extremely fast because we made custom ASICs to implement our Time Lording.
Interesting. Oh, wow. You guys built custom ASICs?
Yes.
That's so interesting. And what was the problem that made you realize that you had to build ASICs for that?
It's because there's this fear that somebody could manage to get a Time Lord that's faster than other things, and they might be able to attack the network using that. So what you want is to have Time Lords that are basically running up against the physics limits of how fast Time Lords can possibly run that are just doing everything. And that way nobody can get ahead of it.
Interesting. So you came back to ASICs in the end.
Well, it's a handful of them. There's like 20 of these, spread out around the world that are running all the time that are doing it.
Okay.
But it's a minuscule amount of stuff. It's kind of like work equals force times distance, except it's not actually integrating them, it's adding them. So you do it's getting greater efficiency because your force is your proofs of space and your distance is your proofs of time. But it's not having to do both continually all the time. It does the proofs of space and then it does proofs of time. So it's adding them instead of multiplying them.
That's so fascinating. So, okay, the transactions go to the Time Lords, and that's where the blocks are being verified, correct?
They're being finished.
Got it. Okay, okay.
Yeah, there's this kind of continually growing chain that's being made by Time Lords, and you have to like insert the blocks in the correct position for them to go into it.
This is so fascinating. Have you run into any other blockchains that have created an architecture like this? I feel like it's kind of unique. It feels like you organically sort of like had to solve different problems and you landed here.
Nothing so sophisticated. So like Richard C. at Stanford, his group do some related things. And actually one of their observations made a big difference in what we're doing. And that's the basis for, I forget which blockchain. But they pointed out that if you have all the challenges for a given long interval all come from the same place, then the amount of gaming of it that can be done by whoever it is that last has the ability to touch the challenge is greatly reduced. And when you're using proofs of time, the thing they got kind of off with that is it's actually much better in a given epoch to make it so that the challenges for the next epoch come from the first block in the previous epoch rather than the last block in the previous epoch. That way, whoever it is that made that block is indirectly exerting some kind of control over what the challenges in the next epoch are going to be, which might favor or disfavor them. Like a big enough cabal could say, oh no, this is not going to work out for us in the next epoch, so we just won't publish this block. But that doesn't work because they don't know what the challenges are going to be yet. And if you withhold it, then by the time you find out what the challenges are going to be from it, it's too late because you've been orphaned already by then.
Interesting.
Yeah, I spent 2020 figuring that out.
And then talk to us a little bit about what throughput are you able to hit with the ASICs and the Time Lords? Like, what was it like before and how is it now?
So it turns out AVX 512 is actually pretty good at this. So roughly speaking, AVX 512 is able to do around 250,000 iterations per second on the verifiable delay functions, and ASICs can do about 1,000,000.
And for those that may not know, can you tell us a little bit about what AVX 512 is?
Oh, AVX 512 are some instructions that are on the Intel chip that do fancy stuff. People think of GPUs as being very fast, which is true, but they don't have very low latency. They have very high throughput. So if you're doing a lot of calculations in parallel, GPUs are really great for that. If you have something that is by design extremely sequential, as proofs of time by definition are, then it really needs to be doing it on the chip. And so AVX 512 is really good for that.
Interesting. And what's the best way to think about like what throughput is possible? Is it in terms of like block sizes that are passed through or block times? What's the best way for listeners to sort of understand that?
There's a few metrics on a blockchain. One of them is what is the latency to get transactions in, right? And then how many transactions can it handle? And when it's going at full bore, how big is the blockchain as a result of that? So Ethereum is actually pretty poor at this because it's not very efficient in terms of how transactions get encoded and such. So Chia handles about 40 transactions per second, depending on what you mean by a transaction. Like there's bigger and smaller transactions. It's basically comparable to Ethereum in terms of its potential throughput that it can do. Now, the difference is that in Chia, you can have just like a super low-end computer running a full node. And the size of the blockchain growing is nowhere near as fast. And that's just due to better engineering, due to the on-chain programming environment having a bunch of advantages to it.
So that means the carbon footprint of the chain is fairly low, right?
Yeah, yes. It's higher than we would like right now because of these like grindy trade-offs people figured out how to do. So we're working on fixing that. Actually, one of the people who figured out the attacks is working with me, and we're working on the new proof of space format that get rid of those problems. But yes, the carbon footprint is much, much lower. And that's part of why like carbon credit things are willing to work with us. That's one of our big projects.
Amazing. And was this chain written from scratch?
Yeah. I originally thought it would be a good idea to start with the Bitcoin code base, but that was not happening. There wasn't really anything salvageable from that code base, unfortunately. So instead, it takes all the Bitcoin concepts and makes them better.
Does it have a scripting language?
Yeah, it's Chia. It works in the CoinSet model, which is basically the UTXO model, with some clever tricks added. Actually, it turns out you don't really need to add anything to it. It helps to dumb it down in certain ways. So Chia actually supports covenants and capabilities, which Bitcoin does not. And it does that by first off supporting a Turing complete environment, but also just using some clever tricks, which the environment is designed to make relatively easy to do. It turns out, like in principle, there are these tricks you could use to have covenants and capabilities in Bitcoin. Well, people knew about the tricks to do covenants, and I figured out a silly trick to add to that to support capabilities, and then designed the entire on-chain programming environment to make those work.
What are the application layer sort of features that are possible with covenants and capabilities? Like what doors does that open?
Well, in terms of specific end user features that you can have, a good example is you can have like a vault, your wallet, and people can send you money in a pay to singleton payment where there's this coin that's on chain that's able to absorb this payment because you sent it to that thing. And that actually is based off of a singleton, not off of a like public key. So you could actually still be able to like rekey your vault and have all kinds of complicated access controls to it. And this works, and you don't have to change your address over the course of making these upgrades.
And talk to us a little bit about some of the cases in which someone may want to use that.
Oh, doing good self-custody is just like job one of smart money. It's just like the very most basic thing that you should be working on. It's what I've always been very excited to work on. We have our new wallet architecture coming out soon, and the second iteration of that is going to have really, really amazing self-custody stuff in it. That unfortunately people don't get very excited about that stuff. That's stuff that like CFOs and boring people get excited about, and most people want their Ponzi schemes.
I think, yeah, like looking at some of the newer chains that were also written from scratch, I think the one thing I noticed was there was just an oversimplification of the key model. And I think, there's a lot of cool things that can happen if you can do what you're saying is possible with Chia. And that's like if one of your keys gets compromised, but you want to keep accepting payments at a certain address, well, you'd like to rotate the key without sort of changing the payment address. And there's other like use cases. I think, if you're a company, you have a corporate treasury, someone leaves, you want to be able to swap that out as well. And so there's a lot of like real world use cases, I feel like.
Yes. Yeah, this is all very, very important stuff. And so the new wallets that we're working on are going to have better self-custody than people are used to with Bitcoin. And then the iteration past that will be much, much better than like big companies get from their banks. So it'll actually be like a really compelling thing that has like really, really well thought out business logic of what you can do when you have all these features around like what's the logic around rekeying. And when you make a payment that's like a clawback payment, what's the logic around clawing those back? If you don't want something to have clawback at all, it can be rate limited. So you can send out funds immediately, but only at a certain rate, like those kinds of features.
It's kind of funny in this space. I feel like there was a lot of R&D around custody in like 2015, 16, 17. And then Ethereum launched and then everything went quiet on the custody front. Like they had MetaMask, but I wouldn't say the security moved forward very much, or like you didn't have role-based access control and things like that. And it's interesting. Like I feel like no one's done R&D on the wallet in like a very long time.
Yeah. Really, all the custody stuff is just like multi-sig. And you can do much better than just multi-sig by incorporating a time element where things take a certain amount of time and there's opportunity to respond and stuff like that. But I think, well, there's two things. One, it's actually surprisingly tricky to do it right. So I've now gone through the exercise, and it took me several iterations to really get it to the point where I feel it's right, of like working out what should the business logic be behind access control to a wallet. All right, like this sounds like a simple thing, but it's very, very subtle. And there's a lot of edge cases. And I mean, you try to engineer out the edge cases, right? But working on it is really terrifying, not because you're doing anything wrong. Like quite the opposite. It's like, oh my God, this is security 101, and I've never heard of anybody doing this ever. It's like, what the hell? This should be like commonplace. This should be like one of the first things they teach you is explain how this works.
I agree. I think just a lot of developers are focused on just like different things. I think when Ethereum was coming about, they were just focused on what are the cool new, smart contracts that we can create and what can they enable. And so I feel like focus shifts, but also like expertise. It's like you're saying, there's not a lot of custody expertise in the space anymore.
Yeah. Well, I don't think there's that much custody expertise on planet Earth. But the other thing is, people just want speculative investments. They just want more tools to make more speculative investments. That's kind of the big push is for that, not for security, unfortunately.
Yeah. I think the time element is really interesting because it sort of opens up like a paradigm. It's like a new fundamental and opens up a paradigm where you can do more sophisticated things. And I kind of like really like that about the structure. Traditional banks use time delays in a lot of cases as well, right?
Yeah. There's a lot of that going on. When you have funds in a bank, there's a lot of security features on it that are a real service that the bank is providing for you, but there's no transparency or user control over these things at all. And they're not done terribly well. They're done to some extent. And with blockchain solutions, Bitcoin is far worse because it feels like carrying around suitcases full of $100 bills. But in principle, blockchain should be able to do this like vastly better.
Yes. Yep. And going back to this Chia Lisp, can you talk to us a little bit about, I'm assuming it's written in Lisp, but what's sort of like new and different? What should developers know about it from your perspective?
Well, it's in the coin set model. So it's like, in Unix, everything is a file. In Chia, everything is a coin. It comes from, in Bitcoin, everything is a UTXO, which is basically the same thing as a coin. And this leads to like the on-chain state being very simple and very easy to reason about. And the reason why the on-chain language is a Lisp is because it sandboxes things. When you need security, you need things to be sandboxed. And the easiest way to do this is just make it so that everything is sandboxed all the time. So the way a coin gets spent is the coin has a puzzle, what is in Bitcoin referred to as a script pub key. And so there's a script pub key hash in the coin identifier. And to spend it, you need to give a reveal of the puzzle and a solution to it. And then the puzzle gets invoked and it gets past the solution and it returns conditions. And the conditions can be things like make these outputs, pay these fees, send these messages to other coins, require this signature be in the aggregate signature, that kind of stuff.
I feel like this R&D should be getting pulled into other chains as well. Like it feels like pretty impactful.
Yeah, it feels to me like this is just clearly the right way of doing everything. It's not optimizing for what a lot of people want to optimize for, which is the ability for like a web developer to spend an afternoon learning Solidity and write their first smart contract. It's like, hey, it works. Let's put $1 billion on it. Right. Okay. So unfortunately, doing things in this way really requires that you follow the very most stringent set of best practices for doing Solidity that anyone has ever proposed all the time. It just requires that you do it. You have no other option. You must. And so that isn't the most user-friendly thing in terms of building stuff. So we've been working on making the environment much nicer. So there's the lower level thing that actually runs on chain is called CLVM. And the higher level language is called Chia Lisp. We also often say Chia Lisp to include like the way coins work and the conditions language and all that stuff.
Can we start with something you mentioned a couple times, the coin set model? Do you want to tell us a little bit about what that is?
Yeah, well, just everything is a coin, right? A cryptocurrency is a secure distributed database. That's just what it is. So there's a question, what does it remember? And in Chia, it remembers a set of coins. And so every coin has an amount and a puzzle hash and a parent and a birthday. And that's pretty much all that there is in the entire system. And anything that you do has to be a coin. Now, this is actually very powerful. This is a very good thing once you get it working, because everything interoperates. Everything's just talking to another coin. It doesn't need to know anything about the internals of that coin. So everything can interoperate with everything else. Everything is very nicely extensible, but it kind of front loads the pain of forcing it to all work this way. So we have like an asset token standard in Chia, which is a colored coin standard. But unlike colored coins in like Bitcoin, smart coins can actually verify the integrity of other colored coins on chain. You don't have to be running a full node to do that. So things can interact with them, which allows bits of functionality like we have offers. So if there's like, if you want to trade a certain amount of some asset token for a certain amount of Chia, you can make a partial transaction called an offer, which makes some amount of that token go away and just prints a certain amount of Chia for yourself. Now, this doesn't work. You can't do this, so it's not valid yet. But what I can do, you can send that to me, and I can make something that balances the other side of it. I print a balancing amount of the token, and I make a balancing amount of the Chia disappear. And when these are combined, this is now a valid transaction and can go through on chain.
Interesting. It feels like the fundamentals that you're putting together, it feels like a much more powerful DeFi ecosystem can be possible on Chia.
Well, yeah, that's the plan. Thinking that. The world is not acknowledging it yet, but I believe that's the case.
And you were starting to talk about the CLVM, and I just wanted to clarify the coin set first, but tell us a little bit more about the CLVM, what's unique about it, what's better, et cetera.
Okay, so CLVM is kind of like the Lisp version of machine code. If you're familiar with the language brainfuck, it's kind of like the functional programming equivalent of brainfuck. So that's meant to be something that you don't write in the raw, but you have some compiled language that compiles into it. So there's the language Chia Lisp that compiles into CLVM. And because that's a compiled language, we can update it without changing anything at consensus layer, right? And so we've been working on improving that over time, so it's much, much nicer to use than it was before. So there's lots of improvements in that have happened. And also we have these reference things that show people how various and sundry things are done. We have singletons, which is what you use for vaults. We have the asset token standard. We have data layer, which is basically just reporting a Merkle root on chain. And yeah, I'm actually working on peer-to-peer gaming right now is the big thing that I'm working on.
Interesting. So like Web3 gaming stuff?
This is like peer-to-peer poker.
Interesting. So peer-to-peer poker on chain.
Well, it's backed by the chain. It's anchored to the chain. You're playing in real time. Like you don't have to wait for, it's not like there's some transaction on chain for every single move that we do. We're playing in real time, but it's played over a state channel. So the way this works is if there's a problem, if there's a dispute, then it has to fall back to chain and whatever hands were pending at the time the dispute happened get played out on chain.
It's funny, you're bringing back the blockchain's greatest hits. So state channels.
Yeah. Well, Satoshi had an implementation of poker in the original Bitcoin. I don't know what it did or what its scope was, but
yeah, I think stuff like that I think they're called like casual gaming. Like I feel like stuff like that probably sees the most usage out of all the games that are out there.
Yeah. Well, poker is its own weird corner of the gaming world. And having worked on games for this, I think I kind of have a pretty good understanding of what's like special in poker. It's a good fit for this sort of medium because poker is already a game designed to be played between assholes who don't trust each other. So as a result of that, it has these like core features around that. Like you can basically just rage quit in the middle of a session, right? Like a cash poker game is not one long game. It's like a whole lot of very, very short games, each of which is completely self-contained. And because the fallback is to play on chain, which is very slow and expensive, and you really want to avoid that if at all possible, you really want games that have very few turns in them. But then how do you make a game that actually is really an interesting game with very few turns in it? So poker gives a pretty good answer to that question. And I have a suite of 3 games that I'm putting together as the initial games supported by this thing, and a kind of interesting poker variant.
What are the other games?
One of them is basically 2-player Wordle, that both players pick a word out of the dictionary, and then the other person you play 2 of these going either direction at the same time. So in one of these, I pick a word and you try and guess it. You get a Wordle clue after each guess. And if you get it on the first or second guess, you get 100% of the money at stake. And on the third guess, 20%. On the fourth, you get 5. And the fifth, you get 1. If you don't get in 5, you get nothing.
I'm a big backgammon guy. Any backgammon on the roadmap?
No, because backgammon is a long game.
Yes, it is.
Yeah, so you need these like games where you're really like have very few turns, which wind up being these games where you're really trying to outguess the other player, where like your moves make very little sense in a vacuum. Like you have to be thinking about what the other person was thinking that you might be thinking.
Interesting. Okay. Going back to the CLVM, talk to us a little bit about what's new and different, what's more powerful there. And yeah, just tell us a little bit more.
Yeah, so it's a pure no side effects list. So everything is by definition sandbox there and has not very many opcodes in it. And the data structures there's only really 2 data structures. There's a string, just an array of bytes, and there's a cons cell, which packs in 2 of those. This is just how a Lisp works in general. Most Lisps have more data, more primitives than just an array of bytes. In Chia Lisp, there's just these rules when you add 2 things together, like how you interpret them.
Why did you choose Lisp?
Because things need to be sandboxed.
Interesting.
It's just a very safe programming practice to have no side effects.
Interesting.
And like, if you have like an asset token, there's this like shell around the asset token that is validating its integrity, that it is in fact what it claims to be. And by having this requirement that it has to have the shell around it, it gives back this capability that it provably has the shell around it that's enforcing these rules about it being a valid asset token. So that thing then has an inner puzzle that it just calls when it's done with its business, right? And it's very important that that inner puzzle that it calls can be able to do whatever and not be able to reach its tendrils outside of its business and change the data of the outer shell and steal money.
Talk to us a little bit about your asset token standard. What's built into it in terms of like rules and things like that?
Well, you can have any issuance rules that you want for it. And whenever it's doing a transaction, it can invoke something saying, here is the tail of this particular cat that controls its issuance rules. And that might allow you to create or burn some of it as appropriate. When you're not invoking that, which you usually aren't, then it has kind of the normal coin rules that there's the amounts of these things and the net amounts must be the same, right, with each transaction. So you spend a certain amount and they create new coins. And there's not a clear like line of what created what. There's just this rule that the aggregate amount created must be equal to the aggregate amount spent.
And can you set like rules for why or like when things are allowed to transfer? I'll give you an example. So at some point, we made something called ERC 1404 to enable registered securities on the blockchain.
Yeah.
And basically, you can do some like rule checks before a transfer occurs. So one thing that you could do with it is sort of like a preventative poison pill provision. So you can prevent anyone from amassing over a certain amount of tokens or a certain amount of percentage of the supply.
Well, that specific one would be hard to do because these coins don't know about each other necessarily.
I see.
But You can definitely have some kind of rules, like say requiring that someone have some kind of certification that they're an accredited investor or something like that. Those can be created. You can actually put covenants in the inner puzzles. So it's like the CAT standard in the shell is enforcing the capability of it being the asset token.
Interesting.
But in the inner puzzles, you can put another shell around those to enforce some kinds of covenants, which might be like, the original issuer can claw it back or something like that is not uncommon.
Wow, interesting.
We haven't implemented that yet, but that is how you would do that.
Got it. Okay, okay, okay. What sort of assets do you envision? Is there sort of a roadmap of what you're hoping to get onto Chia first? What are you envisioning there?
Yeah, well, there's some stuff being done already. There's a real estate project that's going on right now that's very real. And our big beachhead thing is working on carbon credits. We really want to get all the carbon credits having liquid markets on Chia. And we've got it so that a lot of the auditing of carbon credits is just kind of quietly happening on Chia these days. But there's a bunch of stuff to happen to really make the carbon credits work well. In particular, you need this like commodification. You need to take like a whole bunch of carbon credits that are reasonably comparable in terms of quality and shove them into like giant pools together and tokenize that as a group so that you can get a liquid price on a large amount of stuff. And this is a problem for that industry just in general, not doing a great job of it. But that's kind of necessary because what you really want in carbon credits are for there to be laws that if you have a certain amount of emissions, you have to acquire carbon credits to balance it. And the laws need to have something they can point to say this is a valid thing for you to buy. And right now there isn't that thing.
Are you guys partnering with other firms that are doing the carbon credits on top of Chia, or is this sort of an in-house initiative?
We're working with World Bank.
Amazing. I've been hearing a lot about carbon credits, and it sounds like the standardization of everything is a little bit difficult to do. And I feel like the rules that you're able to set, on your chain are sort of solving some of those issues that you run into, like you mentioned, with the auditability. And I think like one of the hardest parts is like the third party audits need to be sort of tracked somewhere as well. And how do you make sure like all of that's true?
Yeah. Well, we are doing auditing right now. So we are doing things where owners of carbon credits are reporting on chain where those are going. So that creates this audit trail that you can't retroactively change that's showing that. And that's actually actively in use.
Interesting. And are you looking to bring other types of assets? So I think carbon credits are really interesting because the regulations around it make it such that you don't have to treat it as security. And so it's sort of like easier to get to market. Stable coins, easier to get to market than securities as well. The infrastructure is, more lightweight. What else are you foreseeing sort of like tokenized stocks or what's exciting to you?
We have a project that I can't really talk about yet that's in that space, but unfortunately can't talk about it yet. So
Okay. And what are some other like main initiatives? It sounds like asset tokenization is really the main go-to-market now. Is that correct?
Yeah, although I'm very excited about the peer-to-peer gaming that I'm building. That will be out in not too long, and I think that's going to have really easy adoption. And it has very meaningful benefits that because there's legitimately no nudge, nudge, wink, wink, there really is no casino and no rake. This has two big benefits. Number one, you're not losing money to a casino. And number two, you can do it legally in many, many more places. There's meaningful differences in how the law views games of skill versus games of chance and gaming played directly against other people versus played in a casino.
Yep. Interesting. And have you thought about prediction markets at all? Like, are those interesting to you? And do you see a future for those on Chia?
I was asked about this and I have a plan that I worked out recently, but it's a little bit further off in the roadmap right now, where you want it to be that people can create a future based off of something, right? But rather than requiring that there be this super reliable oracle that's like predetermined that it's going to adjudicate everything that could ever possibly happen in advance, which is expensive and limited and blah, blah, blah. You instead have an arbitrator. And so two people put together a future, and there's some somewhat subtle logic where if there's an issue, if they don't agree on what the actual outcome was of this future, of what actually happened and where the money should go, then they basically both post fees for the arbitrator, and then the arbitrator steps in and decides where the money goes. And the person who won gets to keep their arbitration fee, and the person who lost loses it. So That's my plan for how this should work, which I think is a better approach than using oracles, at least for certain kinds of things. For some stuff, if there's something simple that a lot of people want to put futures on, then you should just use an oracle. But this is more stuff it can touch.
Interesting. Do you think the Oracle solution is sort of like an existential risk to the prediction market space?
Well, there are definitely things that have screwed it up really, really badly in the past. Trying to make it so that the oracles are like this amorphous thing and anyone can act as an oracle and you somehow make this vaguely trustworthy, somehow people have tried that and it doesn't work. You really need to have some trusted third party who's actually trustworthy for this to be functional at some point.
And at Chia, how do you think about like team building? How do you attract folks that are able to get to the same level of technical depth as yourself?
Well, Chia is a very mission focused company. I think it's very good for just having a good team when there's a clear vision for what you're doing that people believe in and care about.
What is the mission of Chia?
The mission of Chia is to make smart money ubiquitous in the world. And there's a bunch of specifics that are part of that, but it's really this broader thing of having smart money that actually works and is actually doing stuff.
Interesting. In terms of like the engineering depth, I guess, has like most of sort of like the primitives already been like this is in production. There's some R&D going on with the proof of space and time. And so how do you find folks like that? Are there folks doing research on this actively, like in the academic space?
Well, first off, the people who managed to find grindy attacks on our proof of space sort of volunteered themselves, right? Because they started setting up services that did that. So that was annoying. But, I'm working with one of those people now when we actually acquired what he had. So we had this problem that our Nakamoto coefficient was going down because of one of these vendors who is not speaking a proper pooling protocol. So we acquired what this other person had made and set the fees on it to 0 for people to use. And that's helped with our Nakamoto coefficient. Our Nakamoto coefficient continues to be better than anyone else's, which is a bit of a low bar, but we want it to be much, much higher than it is right now. Yeah. And so, with proofs of space, another person on the team was just like writing plotting software. Yeah. And there's an intern who's a kid I know from math stuff. We've had a bunch of employees for a long time now. There's a bunch of people who've been at Chia for a really long time.
It's kind of funny. Like, I feel like the early days of Bitcoin, you kind of knew everyone that could do anything. All the development, I feel like, was like really public. And so you know who the good developers were. And now it's a very noisy environment and it's hard to find the signal, I feel like, in the hiring pool.
Well, Bitcoin development, unfortunately, has really slowed to a crawl at this point.
Yeah.
It's getting, basic maintenance, but in terms of actual enhancements, it's hardly getting anything. Although Anthony Towns is working on making a Bitcoin Lisp based off of Chia Lisp. So that's kind of neat. I hope that gets somewhere.
Interesting.
It's going to be a slow process at best, but I wish it will.
Yeah, it's like, does Bitcoin need to have better R&D and innovation to reach a large market cap has unfortunately become the question.
Bitcoin has a large market cap and it has not had very much R&D.
Exactly. And so it's like, well, if there's no incentive, then that might be just what we have, on an ongoing basis for Bitcoin.
Right. That's my anticipation, is that will continue largely as it has. And unfortunately, a lot of other chains, really all they're doing is like, well, we'll add in Turing completeness and then we'll just add on chain scaling by just making it so there's hardly any full nodes and it's pretty darn centralized.
Where's the majority of the users for Chia?
Oh, it's smeared over the entire planet. It's all over the place.
It's amazing. I didn't really talk about future roadmap. Is there anything there?
So I've mentioned a few things, right? Well, I mentioned the arbitration thing, which is a relatively new idea that I just came up with a few weeks ago and we have not started development on. And there's the next generation of our vaults that are going to be really amazing, which we have mostly planned out at this point. There's gaming, which I'm actively working on right now. That one's just getting out of being a science fair project. That was a very big lift on a technical level, getting it to be able to work at all, because it's asking a lot for true peer-to-peer gaming to make it so that the other person can't, cheat, but you can still play in real time. But the core of it is basically working and tested at this point. So it's getting more into just normal software development on that project.
Amazing. That sounds exciting. And where's the best place for folks to try out the gaming once it's live?
Well, if you just follow Chia, I'm sure we'll have big announcements of it when it's ready. That one's going to be a multi-step thing in that there are going to be trackers for people to find other people, and our reference tracker is going to be intentionally very minimal in the list. This is a lot like BitTorrent, right? That there's a tracker that connects people to each other. So we're going to have a version out of it when it's kind of in a reasonable-ish beta, where we show people how it works and then want to coordinate with people who are like making trackers and such, so that we can have a rollout with some of those things actually supported pretty well.
Amazing. You can follow Chia on X or Twitter, whatever you call it, at Chia_project. And we have the Chia Discord at discord.gg/Chia, Chia, chia.net for the website. How did you come up with the name Chia?
I don't know if I'm giving away the game here, telling a real story instead of making up some frou-frou bullshit. So something I knew from experience is before you really have much of a company, you need to have picked a name and a logo and just say, we're not revisiting the name and logo, and tell people to shut up when they suggest they might want to revisit the name and logo. So we were discussing what the name should be, because I liked the name Bram Coin because everyone told that joke. And I figure, well, if everyone tells the joke, you should go with it. But people hated it as an actual name. So we need to figure out a name. So we were discussing it, and I said that I'd come up with the term farming instead of mining. So people liked that idea. So I went and looked up grains. There's just like a Wikipedia page that's like a list of grains. And I went down the list and I was looking for your basic criteria in a name, which are people should be able to spell it. Someone should be able to see it, mention it to someone else, and that person should then be able to search for it and find it, right?
Yep.
And it should have generally positive associations and be available from a trademark standpoint.
Yep.
So went down the list and Chia was the obvious winner. So that's where the name comes from.
Bram, thank you so much for joining us today to tell us more about Chia. We're definitely really excited to see where this goes with asset tokenization, with the gaming that's coming up. It was a pleasure having you here today.
Yeah, great being here.
Thank you.